This video is kindly sponsored by Project Red. Check the link in the description to find out more. Hello everyone, welcome to Meet a Maker. This week we have wonderful co-host Faye. Hello Faye. Hi.
Good morning everyone.
And this week we are meeting an amazing human by the name of SJ. Hello SJ.
Morning.
How are you? Very, very early in Florida.
Yes, thank you for joining us.
It's like 5:30. It's fine. This is fine.
Thank you so much for coming on. I really appreciate it.
Dedication. Everyone take note.
Yes.
This is dedication.
Definitely. Right. And Faye and I are such fans, so we're very, very happy to have you here.
We're very pleased.
Yes. Shall we dive in though? Who are you? What's your day job? And what do you do?
Who are you is heavily loaded, so I'm gonna skip that one and come back to it.
Okay, come back to that
one. My name's SJ. I'm a metal additive engineer. So that's my day job. I print in metal, where everyone else gets to do cool things on presas and like 3D print mills. Shout out to Naomi for being awesome.
Hell yeah.
I've been doing metal additive for about 3 years now, I think. Somewhere close to there. And I used to work in aerospace, but now I'm working in clean energy. It's awesome.
Amazing. And wow, like metal printing is like so cool and like a totally different realm to anything I've touched before. So like, I don't know, what's it like?
Well, I think it's so funny that you're like, oh, plastics, that's so cool. And
yeah, we're just
Billy
like,
and I are
metal.
Going, metal? What are you talking about?
Well, you guys can do things in plastic that, like, I know I look at them and I'm like, that would never print. I'm like,
true.
That's a recoder crash. Yeah.
What's a recoder crash?
So, like, you know how you have, like, the extruder nozzle in FDM printing? Is that technically the term? Is it FFF or FDM? We'll go with FDM for this.
FDM is what everyone says, though I think technically Stratasys owns that or something, but everyone says FDM, so whatever.
Yeah, I always understood
it's fine.
It's fine.
So the way it works in metals is there's like a laser that comes in and it passes through a lens and then it hits something called a galvo. And the galvo is basically just like a mirror like that can like do this. And so like this is your first angle and then there's a second angle that comes off. So it goes boom and then it comes down like boom. And then down here is like the powder bed. So like there's no extruder nozzle. So like the laser's just like hitting the powder bed and then you have to figure out like, all right, cool. So I got the laser to work. Now how am I going to keep putting material down? And so that's where like the recoder system comes in. So like you have the powder come up on one side and then it like the recoder arm comes across and it's like,
it's like,
and it like
dusty thing.
Moves the powder across the plate.
Gotcha.
Yeah, it like slightly dusts the plate and then the laser goes again and that's basically the science. That's like the kindergarten version of what I do all day. Is I just literally sit there and watch the laser weld all day, every day. It's slower than watching FDM extrusion.
But it's more exciting. I mean, you're making stuff in actual metal. Like, that is so cool.
Yeah. Real world usable parts as opposed to tchotchkes. Admittedly, as soon as those words left my mouth, I realized there's tons of real world usable purposes for FDM printing.
You've got one sitting over your shoulder, actually, in rainbow colors, right there.
Yeah. No, absolutely. Obviously, I don't actually believe that it's just for tchotchkes. But there is something obviously very different about a part being made in metal and what it can be used for, I guess, versus something made in any type of polymer, any type of plastic polymer. Just very different use cases. Am I correct in thinking that the form of metal printing you do is sintering?
Yep, that's correct. It's called DMLS, direct metal laser sintering.
Nice.
Okay.
And does it like get stuck to a bed? Like, how do you get the part out? Sorry, I'm asking really newbie questions.
No, ask me all the newbie questions because I feel like I've talked with you about what I do, but I've never explained it like scientifically. I just tell you that it came out the printer.
Yeah, and I'm like, wow.
So most people watching will have no idea about sintering, like at all. Might not have even.
Okay. So my my metal specialties are aluminum, which everyone loves because, like, if you talk to any CNC machinist, they'll be like, "No, I'm not going to do that," and then you're like, "Oh, but it's aluminum," and they're like, "Aluminum, you say?" Well, I mean, of course I can do that.
Why is it
Because
just
it's
really
such a
good to work
soft
with?
metal.
Ah,
It's
okay.
easy to work with in a lathe, and it's like it's really easy. Like, you could do a lot of like machining by hand.
It's
So
light and soft.
And does that make it
yeah,
easier
but
to print too, or does that make it easier to print as well?
no.
No. Okay. Good to know.
Yeah, and then my other specialty is what like my Twitter handle is, which is Inconel, which is a nickel super alloy. Yeah, it's like, I think in my head, it's the closest thing to like vibranium that we have.
That is amazing. That is amazing.
So now you see why I had to be called Inconel.
Yep.
But yeah, so Inconel is like a nickel super alloy, and like one of its main properties is like that what they use it for in aerospace is that like the more you hit it, the stronger it gets.
What?
So like I'm not a metallurgist, so I can't tell you like how the atoms move, but like the more you like strike it, the harder it becomes. It's like a weird thing. You can look it up on Wikipedia. Check me in the comments if you want. I've had to try and machine it, so I know for a fact. That is ridiculous.
That's incredible.
Yes. It's really cool. So they used to put it on like the hulls of the spaceship because like as it was re-entering the atmosphere, it was one of the few materials that could survive really, really well.
Right, of course.
Yeah, but it's super expensive to machine because as I said, the more you hit it, the stronger it gets. So just imagine trying to like hammer away at something like that or grind away at something like that.
Is this like
in
one
like
of
your
the
CNC
situations where you have to use the metal to machine the same metal, like almost like diamond, kind of? God,
it's kind of like that. It's kind of like that, but we actually end up just like it's like if you were gonna do like a lathe project in aluminum, you would only need like one bit. But for me to do the same operation in Inconel, I would buy like 4 just to be safe. Because it's just it's gonna break. Like Inconel's like super strong, so you're just gonna lose a few bits in the process.
Wow.
So that's what also makes it like super expensive. Because then the machinist has to stop, break everything down, reload his drill bit, start it all back up again. And yeah, so henceforth, why it's super popular to 3D print Inconel, because then you can just get it into the net shape and all you have to do is go in and like put a hole in here or touch it up around this edge and then bam, there it is.
Right, of course.
Instant part.
That makes so much sense. Amazing.
I'm guessing it's not really any different to print in Inconel versus aluminum. Like I'm guessing the process is more or less the same for different metals.
The process is roughly the same. Okay. But like there's like, I mean, obviously parameters like laser speed, wattage / power, like your cross hatching, the patterns that you laser it in are different. The way metal lasering works is it's kind of like, it was described to me recently as a coloring book. So like you have the contour, which is like the outlines of your coloring book, right? And then the striping pattern is like your crayon going back and forth between the lines.
Gotcha. Yeah. That makes sense.
So like that's kind of how it goes, and that's kind of how it looks.
I really like that metaphor. That's great.
Yeah,
it's like FDM works in a very similar way, where you have your out, you draw your perimeters, and then it goes back and forth to do the fill. So it's not a million miles away in terms of like, I guess the logistic. No, that's not logistic.
Yeah, but the main difference I would say for me personally between Inconel and aluminum is that I'm far more careful with my aluminum, because aluminum and titanium, because of the way that they are, like the size of the pores and like the size of like the particles of the powder, if you like get them going, it's like striking like tinder. And so like sometimes like the condensate will like just combust or ignite, or I'm trying to figure out the right vocabulary word. But so like as I'm like moving the filter out, like we have to like have all of these safety procedures. I'm in like a full hazmat suit. Because if I'm not super, super careful and I shake it just like a little too much sometimes, like it will just go up in this big green flame.
Wow, I never even thought of that, but it makes so much sense because I think those like survival strikers, they're aluminium and something else, aren't they? Yeah. Wow, that's terrifying. Yeah.
This is
Dang.
I have a great
science
life insurance plan.
Oh, wow. Oh, no. Please never go up in flames. I would miss you sorely.
Oh my god!
You can totally edit that out. Sorry.
No. It's too funny. So,
Oh
like,
man.
the skills that you use at your day job, has that helped you with your own making or in other areas of your life? Like, do you get to use it outside of work as well?
I would say that like for me, like 3D printing has always been my passion and always been like the thing that I've loved the absolute most, more than anything else. It was just like, you know, when I met 3D printing and I met CAD, it was just like, oh hey, like we fell in love, and then like we got married like right after that.
All three of y'all.
All three of us.
When did that start? Like, how did you get into it originally? Sorry, I know I'm going on a tangent, but like...
Oh, no, that's fine. That's a great question. So I started CAD in my undergrad, and like I'd always wanted to be like super artistic, but I couldn't make what was up here happen with like a pen or charcoal. Like I would describe things, but I couldn't get it to like do what I wanted on the paper. Like even drawing rectangles was just like, this is not what I wanted. It's a circle.
Been there.
And I used to get super frustrated. And then I walked into engineering school and we had our first CAD class, and the professor just showed us like boop, boop, boop. And like it happened on the screen. And I was like, oh my God, this is what I've been waiting for my entire life.
Oh, that's so cool.
Yeah. And so then I was finally able to do like all of the artistic expression that like I couldn't do with like a pencil, because that's just not how my brain is wired. So it's wired for CAD.
Yep.
It's really
my
interesting
whole life.
the difference between like how our brains translate. Basically, some people have kind of an inherent ability to translate 3D into 2D and back again, and other people don't. You can, like, 3D has to be 3D. You can't, like, the translation between the two doesn't always work. Like it's something to do with how our brains work, and some people have the skill and some people don't. And yeah, so for a lot of people, something like looking at a real world object and then drawing it in 2D is impossible. It's just the brain goes, no, I'm not convinced by this flattening you're trying to do here. But obviously creating things in CAD is not 2D, it's 3-dimensional, so it accesses like a different part of your brain. And so yeah, I don't think it's unusual for people who are good at kind of 3D drafting to not necessarily be able to draw, because they're totally different skills. They use a different part of the brain entirely. So, I don't know. I think this sort of thing is very interesting.
Yeah, definitely.
And that's why I'm like so like blown away by the two of you, because like, I mean, Billy was like, oh yeah, I'm just gonna start painting and it's no big deal, and then she's over here Pablo Picassoing it, and I was like,
I grew up in a very arty environment, so there's a lot of osmosis knowledge that just probably was gained over the years. Like, it wasn't like, yeah, my yeah. Anyway,
Billy has the good brain connections to turn the 3D into 2D.
That's great brain connections.
But I totally agree though about like digital fabrication, in that, like, because I got into it because I wanted to make things my hands couldn't make. I couldn't make things accurate enough. I wanted to make dice. I couldn't make them accurate enough with my hands, and I knew it. And yeah, like, I love that we have these tools that allow us to be creative in this way, even when our hands fail us, or, you know, like, even, not that your hands were failing you, but like, I felt like mine were. But yeah, like, I love the technology for that.
No, computers are always going to be more precise than human hands, I think. Like even very skilled artists can only work so small, kind of thing. And obviously we can now 3D print stuff to micron levels and stuff like that on a desktop printer. You know, on a desktop resin printer, it can go to what, 0.1, you know, like, or not 0.1 microns, 0.1 millimeters. And yeah, that's but also do it in a fraction of the time. I think that's the other thing, is that like even if you had a skilled artisan who could like sculpt a teeny tiny thing, it would take ages versus a 3D printer, which would do it in like
Yeah.
which is almost insulting sometimes. How dare you?
So you got into CAD first, and then 3D printing. Did that happen later as you were studying, or?
Yeah, so that happened like later. So I took all of these CAD courses, and I minored in CAD and CAM when I was in school. And then they had like a 3D printing class, or they called it rapid prototyping, and I was like all psyched about it, and I was like, hell yeah. And so like once they like gave me the 3D print back from the CAD that I had made, it was one and done. Like I was just like, all right, cool, so this is what I'm gonna do. Like
This is me.
I was like, you have taken the art I made on this screen, and now you have given it to me in physical form, and I want to be a wizard too. Please let me be a wizard.
Yes, it is magic. I tell that to people all the time, that it turns your thoughts into reality, and it's magic.
It's
like,
physical
it's like you can hold it in your hand.
Yeah.
It's crazy. Yeah.
It's like, wait here. I'll be right back. I'm gonna run to my printer. I'm gonna get you I'm gonna print it, and then I'm gonna bring it to you, and you're gonna understand what I'm trying to tell you and describe to you and show you.
Yeah, hold it and feel it and experience it, and it's just the coolest. I will never get over it. Yeah.
Yeah, it is definitely like that sweet spot where magic and sci-fi kind of meet, and that sort of like this is absurd. How is this real? How is this on my desk? You know, like how is this something that I own?
Though we can't own the ones that SJ uses. Oh my god,
no,
they must be so expensive.
They're so expensive.
Also,
and the materials,
probably like
and
my whole flat like would be just one printer kind of thing.
Yeah, roughly the size of it's pretty big.
Wow. What's the build volume?
Well,
then?
like the big industrial ones that we use for like making I don't want to say actual real parts. That's insulting to my little baby, a little baby printer. But the big ones used for like a lot of aerospace production are pretty large. I would say they're like 15 feet by about 6 feet without the steps on the side. And they weigh like a lot of pounds.
This room. Yeah, basically the size of this room that I'm in.
Yeah.
That is amazing.
Yeah. Wow. And that's all to house a build chamber that's only 16 inches cubed.
Oh,
that's a little painful.
Wow. How come? What's the rest of it?
Oh, right. Yes. So I told you about like the galvo and like the laser, but for the laser to operate nominally, sorry, it's 4 a.m. It's 5 a.m. I'm here. Okay. For the laser to operate correctly, you have to remove all the oxygen out, right? Oh. So you have to fill it with argon or nitrogen gas. So like think of that like big 16 by 16 cube, and we just like dump argon into it. Wow. And then we push all of the oxygen out.
This is the coolest.
Yeah, so you have to have systems in place to handle all of that argon flow. And then you need systems in place, like for the big ones, it's built in 3 compartments. There's like an electronics box, then there's like the build chamber box, and then there's like the unpacking box. And they're all separated with all of these seals and whatnot. So like, so like once it's finished building, it'll like drop down, and then it slides along like this belt over to the unpacking box, and then it comes up slowly. And then you have the sucky civvy thing, and then you just like stick it in there, and it sucks up all the powder.
The sucky civvy.
You can clean it up.
Technical term.
Very technical. I was just thinking that.
That's so cool though. I can just imagine this print like rising up like slowly, like here's exactly your new engine part or whatever. Yeah.
Yeah, and then like all of it's just like the powder's just like flowing down around it.
Amazing.
I would love for dramatic background music to play every time I pulled it up, but that doesn't hapen.
You should make that happen. That has to happen. Just get an Arduino and something.
Well, I only have like a pepper on, and it's loud, so I wouldn't be able to hear it anyways. Aww. So it's just in my head where I'm just like,
no, that's fair. That's totally fair.
That's amazing. So cool. Wow.
I want to ask, because I feel like we could probably ask questions about the specific printer for ages, but I want to know how 2020 has kind of changed the way you feel about 3D printing, because it's been a really weird year. It's been a very unusual year, and it's almost over as well, which is wild. But how is it? How has it affected the way you feel about 3D printing?
That's a heavily loaded question. So on the one hand, I'm like really excited because I feel that, like makers really stepped up this year. Like the 3D printing community really stepped up this year. And I mean, like they showed what they were worth. And like, not to knock like my specific set of the industry, but like the maker communities and like the high schools like really brought it out. You can talk to at 3DP girl. Her name is Mara. She works at Matter Hackers, but like I listened to like a talk she gave where she talked about like how like the high schools and all of them banded together to like really save everyone. I mean, I work in like professional additive.
Don't have any idea as well.
Yeah, and I work in professional additive, and like we had to go through all these regulations to make sure that like the product we were putting out was like going to be 100% safe. So we were tied up in the red tape for weeks. Meanwhile, people were at home with their like 3D printers, just like printing it off, like bam, 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 bam. And so like it was just really amazing to see them step up, and I was just kind of like, okay, like I see you, come on, like,
yeah.
And they were able to like iterate so much faster, and I was blown away. I was really impressed, and I'm like really impressed with like how like they just stepped into the supply chain, and they were like, yo, what you need, we got you, like we're here for you, like.
Yeah,
I was just blown away by our community, and I was like, yes, these are my people.
Yeah. Yeah.
It really 100%. Showed too where having desktop printers can actually be incredibly powerful too in a real world sense. Because like you said, rapid prototyping, just being able to design, test. Okay, this is a good one, produce, go. And this can all be done inside of a day, 2 days kind of thing is amazing.
Yeah, like the whole community just shone. It was amazing. Like I really think this was the year where 3D printing proved itself, and open source as well, like those designs flicking around and getting iterated upon and everything. Like fuck, we shone. Like it was amazing, like it was just
so hats off to everybody in the community. We're taking a moment to appreciate you. Like we love all of you. You're out there and you were printing and you were saving lives. We appreciate you and we thank you. So I that was probably like the highlight for me, like as far as printing goes in 2020. That just really blew me away.
Definitely. Yeah. I think everyone probably feels that way. It was
and it's gonna be great for us next year.
Next year?
Yeah, I mean like 3D printing proved its mettle, right? So like everyone's always been like, well, why don't you 3D print it? Well, why don't you 3D print it? And then they're like, I don't know if we can trust this 3D printing thing. It's kind of new. I don't know. And then like,
actually, be like,
if you remember,
saved lives. Remember when we saved all those lives?
Yeah. So like next year, I think there's going to be a big shift in the industry where like 3D printing is really going to come into its own and like really be taken seriously, because I feel like people keep thinking of it as this hobby thing. I don't think they really understand like the hard work and the science that goes into it.
Yeah, and all the possibilities.
The majority of people still have no idea. They really don't. Like the number of times I explain like even just that it exists to lay people, like that they don't even know that it exists as a technology. It's kind of like a okay, let's go back to the beginning here.
But like even in industry, like here in Australia, if your car breaks down and you have like some sort of car that's like not just a stock model, you have to wait for parts to come from Germany or America or wherever, and it takes months for that part to arrive. If people could just like push button, print object, that's the thing for the car. It saves all of that time waiting. I mean, it's not that easy, obviously, to print metal. That's why you're an expert who studied a whole bunch. But, I mean, in terms of like it's not going to have to go through all that shipping and all that like carbon cost of the shipping and the storing it and then the waste of stuff that isn't sold and all that other stuff. Like, particularly here in Australia, because we're so far away from so much. Like, I just think, there's so much potential there for that. Because everything we have comes from overseas.
Imagine the carbon footprint that would be saved if stuff didn't have to be shipped constantly thousands of miles, like you said, car parts that's such a good example, because that's something that's like always needed. and probably always being shipped from overseas to Australia. So it's like, if you could just fabricate that in a warehouse in Australia, somewhere locally, where it could just be put on a truck instead of on a plane, like the impact of that would add up real quick, like in a positive way. Like that would
don't worry, we're working on it. Don't you worry.
That's kind of what you're doing, right? Like this is your new gig.
It's kind of like digital. It's called Digital Factory or something like that. Basically, there's like a version of a part that like lives in this warehouse virtually, and then like anytime like the government would need it, or like a car manufacturer would need it, they would literally just go boop, and like it would download the build file, like how you could just download something off of Thingiverse and then just print it, and you could just print it anywhere in the world. And like it would have all the parameter settings and everything saved like that. So as long as you had the same kind of machine and you were using the same like gas and like the appropriate size powder particles, you could get the same part here that you would in Germany.
That's it, sir. It's happening.
They're just testing it out now.
It's freaking happening. That's amazing. Oh, and you're
coming.
Like,
I feel that it's for sure coming.
Hell yeah. That's amazing.
And then you don't need to pay for storage of extra parts. You don't have to pay for surplus. Like companies don't have all this extra inventory where they're like, we don't know what to do with this, but we can't release it to the world.
Yeah. Oh gosh, that's so cool. I didn't realize that's so cool.
Actually happening.
Yeah.
In the works.
Far out. No wonder you love it.
Fantastic. No, that is game changing. That's definitely game changing kind of stuff, especially if it can be implemented on a mass kind of international scale. So, fingers crossed.
Yeah, fingers crossed. It's like clean energy, green.
Yes.
And 3D printing is green too. So like that's also a thing that I really love. We recycle our powder a certain amount of times. It's like after you print with it and it all goes into a bucket, like once you've lazed the powder, obviously it's been burnt, right? So then the particle sizes are bigger. So you can literally, it's called sieving, sucky sievy thing. So you can sieve out the larger particles that are burnt, and then like the ones that weren't burnt just kind of like trickle down to the bottom.
Oh, cool. That's cool.
And then you can just reuse that batch for X amount of times, depending upon your company. Some companies are like, we don't recycle powder here. We're sorry. And then some companies, like they're like, we're sorry, we're just going to save it and keep it here. And then some companies are like, yeah, no, we'll recycle it a couple of times, or like we'll use it for like R&D. Like it's no big deal. Like
that's cool. That's
really
really
cool. Ride that horse till the wheels fall off. Like it's great.
I think that's so important though, because like the last talk I had, like last week we had Amy on, and she was talking. She's a material scientist, and she was talking about the life cycle of objects that we make. And I think that's such an important aspect to think about, is the the waste produced and how you deal with it. And yeah, I think that's a really cool thing, that to be able to reuse it, and that's awesome.
And if you don't reuse it, you can always melt it down.
Yeah.
Give it back.
Yeah. And aluminium's really recyclable, right? Like that's one of the most recyclable things. Like it's very easily.
I think it's one of the easiest to process, recycling wise. I think, unless I'm getting it the opposite.
No, I'm pretty sure it's really easy because it melts at a low temperature and stuff.
Pretty easily recyclable.
Yeah.
I seem to recall watching a thing once, possibly by Penn and Teller, and maybe somebody who has a little bit more background, but I seem to recall watching something at some point about how like a recycling is actually not worthwhile, because the metals themselves are so difficult to process and so difficult to recycle that the energy cost of recycling them is actually worse than making new. But that there was a few exceptions, and I think aluminum was one of them.
Yeah.
Doesn't
sound like Inconel would be there.
No, not Inconel. Inconel's not
like
the easiest.
One time use. Not one time use, but
it gets stronger, so it's a many time use, because it just keeps vibranium. All I heard was vibranium, and now I'm like glowing and like superhero
I'm just
material
thinking
in
of
my
Black
now.
Panther. That's it. That's what I think about now.
Yeah, that's what I imagine.
Worse things to think about. There's worse things to think about than Chadwick Boseman. So I'm okay.
So what about lockdown?
Yeah.
Seeing as we're talking about the year, yeah, how has lockdown affected your world?
Oh man, it's been a nightmare. It's been crazy. So you were there at the beginning, when like I had first like started joining like our group, Women in 3D Printing. Yeah, Australia reached out and they were like, "SJ, we accept you. You can join our group." And I was like, "All right, cool.
Why not?
If it means I only have to wake up at 5 a.m., very low requirements."
We're always getting up at 5 a.m.
Yeah, exactly. And so for lockdown, it was so like with the 3D printing machines, like they have like, I hate that they use this word called production because it's such a like weird word to describe like people just want like a series of parts. It'd be like if somebody called you and they were like, "Oh, Faye, can I get like 15 of your vases?"
Gotcha.
And then you were like, "Okay, cool. So I know I'm going to make 15 of these like in a row for like the optimal size of like the build plate." And so like we're in production. And so like those production parts, they go like, I was working in aerospace at the time. And so they were going to go like onto a rocket. And so they were like, "Yeah, no, we need all of those parts by the end of the year." The way it works in aerospace is that when they fire test like a lot of the rockets, I don't think people really understand like why they're so crazy in aerospace about their schedules. Like any slip in the schedule means that they will not test fire the rocket because they have to have like optimal weather conditions. They have to load like a huge field of like the liquid oxygen and like all of the gases into the rocket. They have to have people on site. They have to have safety on site. Like it's a huge coordinated effort just to turn it on. And they only get to test fire it like what, once or twice a year sometimes, depending on like their budget. So they're like, "No, we need those rocket parts and we need them by the end of the year to get them put into the engine so that we can turn it on." And like, we can't have any slip in the schedule. So everyone else got to work from home, but here I was going into work every day. I was like, "All right, I'm essential. Here we go." But yeah, during the start of the pandemic, a lot of my coworkers were like in contact with someone or like they were at risk. So I was the only one. We went from having like 3 engineers and 2 technicians to just me and the 2 technicians. And we had a print farm of around 20-ish printers. So yeah, I was running like that many printers roughly on my own. My coworkers could send me, like, to be fair, they could send me the builds from home. However, it was really hard to like load them all, purge all of the machines. Purging is when you fill it with the gas. That takes forever sometimes.
Gotcha.
You have to like purge the machines and then like getting all of them started and then like pulling them all out. So like once the powder comes out, you have to like do the sucky sievy thing. And that's a very slow process because we don't want to move the powder too fast and then have it go boom. So
Got
like,
I'm learning.
Going boom.
Yeah.
Yeah. So like taking the parts out of the machine takes like, for like an experienced technician, they can do it in about 2 hours, depending on the size of the particles and the material. And then like me, I'm not an experienced technician, but I could do it in 4 hours. So if I had to pull a machine, that would be like the last half of my day.
Is that like constant attention required, like physical doing of a thing for 2 to 4 hours?
Yeah, it's constantly just like depending on what your site is like. So my site had like a basket almost that had like a mesh screen, and the size of the mesh was like set to a certain particle size, so it would filter out the burnt particles. So like we would just like do it that way. My new site, we do it a different way, but yeah, and that took forever. Just like, and it would vibrate, so it would just shake. So it's like panning for gold, and you're just sitting there like watching it. Like, could you go any faster?
Wow.
Yeah, I'm like, could you go any faster?
And there's no gold.
It's a freaking pandemic and we need these rocket parts. God damn.
Yeah, and you can't just hop from one machine to the next machine, right? Because like you can't cross-contaminate your materials. So like if I'm working on an aluminum machine, I have to stay there. I can't just walk back and forth between the 2 machines.
Oh, wow.
It is official. I would suck at this.
Yeah. I do not
so
have.
impatient.
Yeah. I would
now I'm so
do it for a day and then be like, I thought this was going to be really cool, and now I'm standing here watching the thing shake, and maybe it still would be cool, but I don't know. I think I would have a hard time with that.
Walk away, like I'm frustrated. If I have to sit there and watch the print to make sure it's laying down correctly, like for 5 minutes, that's like, all right, really?
That's
Is this what we're doing?
That's only
like,
the first layer.
What? Yeah. And then if I can't walk away and go do something else and come back to a perfect finished print, I'm like,
that
what?
doesn't need any sucky civvy action.
Yeah, I know. Like, I literally just feed in a bit of filament and do a purge line. Like, this is no, I would fail. I would fail your job. I would walk away.
Utmost respect.
To get
utmost respect to the dedication you have.
Yeah, so it was intense trying to like get all of that going, because like once you like take the part, then once you take the plate out, so like you lift the plate out, right, and then the parts are welded onto the plate, because that's how it works in metal. Like it has to bond to the plate. As like you're lasing between your layers, like it's going through this rapid series of like expansion and contraction, like boom, 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 because of all the heat and thermal stresses, and those stresses build up over time. And so like you'll find that when you print different materials, some of them are like, oh, I'm chill, I'm hanging out on the plate. And then some of them are like, I need to leave this plate, I need to break free. Like that's aluminum, sorry. Stressful. So I tend to apply more supports on my aluminum builds, just because sometimes like it gets a little wily, and I'm like, you need to behave. You're gonna stay right here. You're not going anywhere. But yeah, so you take the part out of the machine, and then it weighs like a ton of pounds. Like our plates are like
literal actual pounds.
Yeah, so it's like a 2-inch thick plate typically of just pure, like, just picture like a 2-inch steel plate. Like that's roughly what it is, and it's like 12 by 12.
Hands, or like
in the smaller machines you can, and then in our bigger machines
like
you actually have to use a forklift.
Yeah, I was gonna say,
wow.
And
then like you like the forklift like comes over, and then you like screw, like it has an attachment to it, and you like lock them all in, and then it like lifts it up out of the machine, and like you move it over.
What?
This video is just gonna be all Billy and I making insane
incredulous faces. They're like, wow. It's amazing though.
Somebody's gonna be making
it's really cool.
Yeah.
I'm lazy though, so I like to carry mine by hand. Like I prefer the smaller machines. I don't have time to go get the forklift and do all the safety checks and go through the checklist and make sure that it was like filled with the last person that used it did it correct. I just rather reach in, grab it, and then like just hold it and walk it to the and then you have to take all the powder out, so you have to like okay, sorry, I have to get a straight face. So once you take it out, you lay it like on its side. So the flat part of the plate is here. So like if this was the plate, it would be like this, and then my part would come off like this, right? Here's a metal printed part, by the way.
Ooh,
and so then you would take a hammer, and then you would just like whack it.
Part sounds fun.
And it comes off with that interface layer. Like,
I have arthritis, so it's like really painful. But yeah, you just like tap the back of the plate repeatedly until you start seeing all the powder come out, and then we like have the air guns, and then we put the air guns in the channels, and then we like blow all the powder out, because you want to make sure all of the channels are completely free and completely clear. It's super critical for everyone who's been like kind of asking me like why I have that cool Solicon video on my Twitter channel. It's because like depowdering can sometimes take days.
Wow.
So like people spend like thousands of dollars on this part, and so the reason they want to metal print it is because they put cool crazy channels on the inside to move fluid or to move heat or whatever floats their boat. And you have to make sure you get all of the powder out, because like I said earlier in the video, that like the stresses are like expanding and contracting, and it wants to lift off the plate. You have to get those stresses out somehow, or the part will deform when you cut it off. So we send it to something called stress relief, where they just basically put it in a giant easy bake oven and they bake it, and they bring it up to temperature, and it like dissipates all the stress, and then they bring it back down slowly.
So kind of like
so that when we cut it
a little
off,
bit, but not quite.
So it doesn't buckle, or like we call it potato chipping. Like it'll literally just like whoop when it comes off.
Wow. That's fascinating. Yeah.
You should be making a list of all these like technical terms.
Yes, I'm liking potato chipping. I will never call it warping again. Potato chipping is way better.
I feel like sometimes my prints potato chip a bit off the build plate. And that's what it's going to be from now on. When it starts to curl up at the edges, it's going to be potato chipping.
That's exactly what it is.
That's what
It looks like a Pringle. It's perfect. It's the perfect descriptor. Yeah.
Chris.
Yeah.
That's it. Potato chipping. No more
It's
warping.
extra crispy.
It's
So yeah, if you don't get all the powder out of those channels, when we go to put it into the stress relief process, it will just bake that powder in and like semi-center it. So
Right,
it'll create a
of course.
blockage. So like when someone runs
That would
fuel
make
through
sense.
it would create a blockage, and then the part would fail during operation. And like I would never want that to happen to like a rocket
Then
engine
somebody
or
lays
what will
it
you. So
down.
like we're very thorough. Like we are obscenely obsessed and thorough with getting all of the powder out.
That makes a lot of sense, though.
Mhm.
Like, yeah, pretty high
Yeah.
stakes when you're building actual rockets. Yeah.
Oh yeah.
Actually,
Speaking of the rockets, this is the F1. Shout out to Thingiverse. This is printed in steel at 30 micron layers. You guys understand what that is because you operate really cool machines.
That's
So this is what like a lattice support would essentially look like.
those are supports, yeah?
Yeah, and you can hear it. I'm like rubbing my finger on this pretty tight and it won't break off. So whenever we have to remove, you know, like Michelangelo with a hammer and chisel, you just no,
Or
it's
a
actually
Dremel?
a hammer and chisel.
No, Dremel
You
is
can use
great.
a Dremel.
amazing.
I use a Dremel to
Not
clean up the
steel.
surface. Yeah,
Yeah,
so
cutting
like
steel, I feel like.
Michelangelo.
yeah. So you see that failed right there. I would take a
Wow.
Dremel and just like clean that up a little bit, but yeah, it's pretty crazy. Like I use like needle nose pliers to pull them off sometimes, and then most of the time though it's like a hammer and a chisel, quite literally, especially for aluminum because it's so much softer. It like gives away in the hammer and chisel game a lot easier.
That is
Yeah,
so
Ink
cool.
and Nail, we know the more I'm tapping on that support, the harder and more
So
painful
how
it
do you
gets.
get it off Inconel? Do you just hope it comes off in the first tap? Or like, what do you do? Do you just not use support material? Just like design
You
it
do
away?
use support material in Inconel, but it doesn't work as well as it does in aluminum because Inconel has different stress patterns. I typically tend to use like a hammer and a chisel, and like you'll find that like once you start hitting Inconel and it's getting harder, sometimes it gets really hot, and then I'll like walk away, and then I'll come back, and then I'll just like keep hitting at it. But also like I've used like crowbars at certain times to like knock the supports off, or like I'll wedge the crowbar in there and like fix the part in a vise, and like I've actually just hung there like on a monkey bar, like just trying to hope my weight like snaps the support off.
This is a very physical job. I didn't kind of imagine it being so physical, but wow, amazing.
No, it sounds incredibly physical, actually.
Yeah.
Is this why you
Yeah.
were so excited about that one metal 3D printer that only required a little bit of supports, that only required supports for like less than 5% or more than 5% overhead?
Yeah.
Velo.
Velo.
About that.
Shout out to Velo. Yeah. Wait, hold on. Velo. Shout out to Velo. Gotta do the little V.
Love it.
What do I do with my hands again?
Yeah.
So is that a new
Velo
model? Oh, sorry.
printers have a recoder system that allows them to go like super low on their angles, so you don't have to use quite as much support. And then the supports that you do have to use, you would just machine those out. And it's a lot easier to use like a CNC machine than to do it manually by hand.
Right.
Now it makes
Cool.
sense.
That's awesome. And is it like, does it pack the material tighter or something? Like, how does it do that? How does it allow you to get tighter angles? Sorry. Maybe that's a weird question.
No, I'm not going to say that's classified because like it's a lot more open now. But yeah, so they have like a special kind of recoder that just basically doesn't use so my machines use like a blade. So it's like a really thin, sharp knife edge that comes across and like grabs the powder and like distributes it. But like when you use that blade, it puts a tiny bit of pressure on the powder bed. So it's kind of like smoothing a wrinkle out of your shirt where it's like, that little bit of pressure can hit the part and knock it over, or it can hit a support and like knock the support over, like if it's not strong enough to like hold itself up in the powder bed. And so that's like why we have the 45-degree rule, that in physics. But
that old thing.
They don't use a blade recoder. I can say that. Yeah, they don't use a blade in their recoder, and because it's a special like magical recoder, and that it eliminates that whole issue. So like because they're not like touching the parts every time they drop powder on them or they bring powder across the plate, they don't have to worry about the low angles, because it's the low angles that really tend to catch the recoder. It's like when you're at 45 degrees and the recoder's coming this way, it's like you're asking for it, buddy. And then when you go below that, you're really asking for it.
That makes sense. Yeah, I keep drawing parallels to FDM, but I'm like, because we have like a Z hop thing, right, where it like lifts up when it's moving around, and I keep like drawing parallels, and I don't know whether they're really legit, but I think I kind of
don't worry,
get
I'm doing it too. I'm doing it too, because that's all I have to go
I can
off
see
of.
it catching and knocking it over though, like that. Yeah, that makes a lot of sense. Wow, that would.
Shout out to Velo, because they're amazing. Keep changing the game. I'm excited. I hope that they just flood the market.
Ultra $2 million, right? It's just $2 million, yeah?
It's somewhere in that ballpark. A lot of companies don't like talking about like how much their machines cost, but yeah, these machines cost millions of dollars.
Yeah.
Let's be real, they cost millions of dollars. It's not a toy, as much as I treat it like one. It's not a toy. It's an industrial piece of equipment. I know that.
We know this. We do. It's not a toy. Every now and again, we print things off Thingiverse, but it's not a toy.
Yeah. Exactly.
Oh, I've been caught.
You said it before.
Nah, if you can't have fun every once in a while, then like, yeah. What are you doing?
Exactly.
Got to be able to have fun. Though that said, if you were to get a second chance at starting again, what would you do differently? Would you do a different discipline? Would you 3D print in a different material? Like how would you do it differently if you had a second chance?
If I had a second chance, I would probably. It's a toss up. I would have. That's a toughie. So number one, I've always wanted to go into mechatronics, which is like robotics meets like telecommunications meets like electronics. Like I'm all about that.
Yeah.
I think that's super wicked cool. It's like the whole Iron Man vibe where he like fabricated it, he designed the electronics, he designed the software, and he like got it to work. I was like, that's lit. And then in a more realistic, feasible sense, if I could go back and do it, I would definitely go back and do trade school. And I would probably become a machinist, just because like you get to work with the metals, you get to see all of the cool parts, but you don't have to put in like all of like the crazy, like weird hours. And then people always need you and they always need your help, and you get paid very handsomely if you get really good at it. So like if I could go back and do it again, I would definitely be a machinist. And you don't 4-year degree. Like bachelor degrees are so overrated.
Yeah.
I would definitely go back to trade school. So
that's really interesting. It was only last year, because I was like soul searching, and I seriously looked at doing a machinist course at trade school here. And now I'm like, if SJ thinks it's a good idea, maybe it is a good idea.
Hiring opportunities are everywhere. It's crazy.
Yeah, like you said, you're never going to not need a machinist, right? Like, yeah.
And they're not going to go away with the increased advent of like technology and stuff like that. Like it's not one of those jobs that's going to disappear in the next 5 years or anything. It's going to be around for a while, because you're still going to need humans to finish machine made parts and et cetera, et cetera. Like it's definitely going to be around for a while. I think. I don't think we're at full automation quite yet.
Yeah. And they definitely understand how the materials work a lot better than I do. So like if I design something for like printing, I won't print it until I have had like a full-on conversation with my machinist. Like, I know I can print this, but can you machine it? Like that's a big part of our industry that I don't think we talk about enough. Like just because you can print it doesn't mean you should. Like how are you going to finish it? So like I'll just sit with the machinist and I'll be like, okay, I want to like cut this like conical piece of support out. Like how hard would it be for you to reach that? And then he'll be like, that's absolute BS. Like, there's no way I'm going to fit that onto the lathe. Like, he's like, no. And then you have to make sure you add, like, datum features so, like, they can locate it. That's one thing I've been learning a lot of in 2020 is, like, making sure my datum features are, like, really easily accessible so, like, they can touch off on certain points and come in at, like, a crazy angle if I need it to be.
What was a datum feature?
So it's like a locating feature that machinists use. So like they have a touch probe. Sounds really spicy, but it's really just like a little needle on the end of like the mill. And so it comes and it will touch like 2 points so that it knows like, okay, this is 0, 0. and you want me to travel 15 inches that way and 12 inches that way. So it's basically just like how you set the 0, 0 on the part. But like you have to make sure that like, because we're machining within like a thou or like 5 thou, which is like a hair size, they really need to know like where the 0, 0 is going to be. It's crazy.
And is the needle
that's what the datum feature is
capacitive
for.
or something? Like, does it, or is it a manual needle that that touches the part, or does it like?
It looks like a needle, but it has like a little ball on the end, and it like has a sensor in it to get a reading.
Oh,
That
gotcha.
makes sense.
So it is
and then
digital
it's like
as well as.
Yeah, it's all digital. Yeah.
Amazing. Wow.
So like, he's not going to measure it with a caliper set. He's going to measure it like with the precisely tuned instrument that's been calibrated.
Reaching in with calipers.
Yeah. And I imagine as the part goes, some of those parts, like some of those reference points would be removed, right? Like as you're finishing things, so you'd need more than one to. Am I right in thinking that?
You're correct.
Okay.
You're correct.
Interesting. Wow. I'm learning so much today. Yeah. This is great.
Yeah.
Just talking to us all the
time. I feel so like outside of my usual realm of knowledge here. It's very much like, oh wow. This is it is I don't know. I definitely find it really interesting how the technologies that Billy and I use regularly and the technologies you use are both considered 3D printing. They both fall under additive manufacturing, and yet they feel so incredibly different. And as you're explaining stuff, I'm just like, dang, wow, it really is. It's massively more complicated.
Yeah, I never had to whack out the organ. And
I don't worry about my prints exploding.
Yeah,
I worry about burning myself. I do worry about burning myself, but mostly because I'm an idiot. And I like to get really close to the nozzle when I shouldn't. But that's on me.
Yeah, it's not explosive green flames that take up the whole room. It's a little different. Yeah.
I've seen it one time, and it was...
Oh, you've seen it? No way.
Yes, I saw the green flames one time, and I was kind of just like, nope, wouldn't touch that with a 10-foot pole. But
I'm out.
Wow.
Sorry, passing on the giant wall of flame.
Yeah.
Thanks.
No, thank you.
Green. Holy. That's kind of cool.
It's magical.
Yeah. Fire.
But deadly.
From a distance.
From a distance.
That's cool.
Yes. Fireworks.
Not
awesome.
Close enough to singe off your eyebrows. That would be bad.
Speaking of things that can go wrong, have you ever taken on a project that ended up being like more than you could chew, or like you couldn't handle it? And like, do you think it was good or bad, if you have been in a situation like that, to have gone through that situation? It's a weirdly worded question, sorry.
So hard. I mean, all the time.
One of us.
Yeah, all the time. But yeah, you'll find like in metal additive, customers like really excited with their part, and they'll like run to you all excited, and they'll be like, yeah, can you print me like 15 of these? And I'm like, why don't you just take a block of aluminum and have them machine out like a folder holding tray for you? Why do I need to print it? It's kind of like very simple geometries like that, where like you shouldn't be using these metal printers to make something so simple. Like you should just go and buy it injection molded or casted or something. Like, why are you asking me to print this? Is it because you think you can get it tomorrow? Like, I don't. But I can't say no, because that's not how it works in corporate engineering. You kind of have to like give them like a soft, let me look at it. Send me your CAD models and I'll look at them and then get back to you. And then it's basically you just quote them a price. Yeah, you just quote them a price so high, they're like, actually, it's really that expensive. And I'm like, yeah.
Oh, yeah, totally. Yeah. No, it's 100%.
But you should look at injection molding.
Mm-hmm.
Yeah.
This is outside of your budget. You should, you should go to this other thing. It'd be way cheaper.
Yeah, exactly. So, like, I get that every day. But I guess if I had to pick one project specifically, my final senior design project was a 3D printing project, because I made it a 3D printing project. And so, so are you guys familiar with hip dysplasia?
Vaguely. Yes.
So hip dysplasia affects like a small amount of children. I think it's like less than 20%, but basically your femur has a femoral head that's like this, and then like your hip socket sits like this, and then the femur sits inside the hip socket, right? Well, in children with hip dysplasia, this isn't like a C shape, it's like a flat shape. So it's
grinding.
It's just not connecting. And so like the babies won't be able to crawl. It'll be difficult for them to learn how to walk. They'll have to like be in crutches or like assisted leg devices or wheelchairs. And so to fix this, conventionally, doctors have this method where they put them in a little harness, like a little jumper, and it forces the femoral heads like inside of the bone, because like when they're infants, like they don't feel that. So it's best to correct it while they're really small. And then like their bones are pretty soft and malleable still, so like you can just like force the femoral socket to make a socket. But the problem is that being doctors, they're not engineers, so like they don't care about repeatability. All of it is done on mostly instinct, like just feeling it and finding the right sweet spot. And so we had a doctor come to us and he was like, yo, can you calculate this so that like I can share it with my community and like we can like be more uniform when treating this for kids.
Yeah.
Wow.
Yeah, so that's how I'm a biomedical engineer. If I didn't clarify that, I was a biomedical engineer by trade before I got into metals. And so I was like, yeah, that sounds challenging. Like we're gonna be on a team to do this. Like, yeah, sure, we can calculate that. And then so we had PhD students calculate like a certain set of angles that they thought would be best for like moving it into place. Like around the acetabular, there's like a little like in the cup there's like a little rim, and so like they would calculate the angles of the energies of like your muscles moving back into the little cup. Anyways, we're getting too big. We're getting back to the overall arching picture.
I'm loving it. I'm following along. I'm like, this is cool. We're on an adventure.
Yeah, okay, so we're on the adventure. So now you have the background of the adventure and why we were doing the adventure. And then a big part of the adventure was he wanted a desktop model so that he could show his other doctor friends like, hey, these engineers tested it out and we know it works, because the main goal of the model was for them to be able to grab the leg, pull it out of socket, and then watch like these muscles suck it back into the socket. You know.
Oh, wow.
So we had to have one team designing pneumatic muscles, which are basically just kind of like these air pressure sleeves. They're really cool if you can look them up. They behave very closely to human muscle. You see them in robots all the time. I'm sure you've both seen iRobot, right?
Yeah.
So like, you know, Sonny's arm where he has the cords and whatever, that's kind of like what the pneumatic muscles look like.
So cool.
So we had all of the muscles that control like the femur and that connect to the hip, like there. And like you were just supposed to be able to pull it out and like snap it in. My job was to 3D print the hip set and the bones that it was going to attach to, which I thought was going to be quite simple, but it was not.
Oh.
So we had the CAD model brought over, like we had the scans provided by the doctor of a baby, and then we had to scale it up because like to print like a baby size, like the baby size of like the baby's hips is like smaller than a mouse. It fit into your hand. I have some pictures. And the femurs are small baby chicken wings. Like their little femurs are so tiny. And so we were like, all right, this isn't going to work. Like this isn't working. Like how are we going to attach these big pneumatic muscles, like the smallest pneumatic muscles, like the size of my finger? How are we going to attach that? Yeah. So we've got to make this model bigger. So they're like, SJ, we need you to print it bigger. And I was like, how big? Like, what's the scale? Like what?
Yeah.
So we ended up doing like a lot with that. Yeah. And then like after that, my first encounter with the maker community actually was on that project, because like I had the 3D printed anatomical models, but like they were like, how are we going to attach the muscles? And I was like, oh, that's a great question. And they're like, could you put anything inside of the print? And I was like, maybe. I don't know. You only gave me STLs. It's not like you gave me actual CAD. I can't.
Yeah. What do you want of me here?
Yeah.
What do you want of me? This is my first solo 3D printing project. I was like, what the fuck? So I went into like a maker community forum and I was like, does anybody have any ideas for how to do this thing? And someone actually replied after like 3 days and they were like, yeah, why don't you just use like metal heat sinks like inside of the bone and then put a screw on the top, and then you can just loop the head of the muscle through the screw and do it that way. And I was like,
Thank
genius.
you,
Yes,
random stranger.
Thank you, random stranger. Make a community coming through for me day one.
Internet actually giving you answers instead of
Yeah.
crap.
Yeah.
Yeah. So that was so that actually ended up saving the project for me. That was my deliverable. So like I definitely thought I'd bit off more than I could chew, just because like getting the print settings right, and then every time I had to like rescale it or resize it, it was a MakerBot. Oh god, I'm embarrassed to say it was a MakerBot when they had just come out with that smart extruder.
Oh, you poor thing. I got in the community way after those happened, but I still hear tales of those.
I got
Weren't
like
they
one
selling
of like
like three for $70 at one point or something? Because everyone hated
they were so expensive when they first came out. It was ridiculous. So yeah, like Faye, if you didn't know, it was like a MakerBot, and it was a smart extruder, and like it would unhook like completely. I don't know what made it smart, but like you could basically take it completely off the machine and it magnetically clipped back in, and so like that made it cool. But that also kind of gave you the hint that like these extruders must clog pretty often if you're gonna let me like swap them in and out like that.
Yeah, so, I can see a lot of ways that would go wrong.
Thing.
And I'm not.
Yeah, so it was going wrong a lot. And then it prints really slowly. Like the prints were taking forever because it took up like almost the whole print volume for me to make the models. So like anytime anybody made a change, it was like, you're gonna have to wait 5 days for that print to finish. I'm so sorry. And then we can start another one.
Yeah.
And we had a deadline. So like I was like stressed. I was freaking out. I was like, this has become way more than I can chew. I was like, I don't know what we're doing. But yeah, whoever in the maker community responded, if you were out there, I'm here today because you helped me graduate. So I appreciate you.
Hugs to that person. Really nice. That's awesome. I wonder if they're still around. Also,
yeah. Are you out there?
Are you out there? Are you listening?
Make yourself known if you remember this project.
Yeah. Extras and Jesus, are you there?
Extras and Jesus.
Yeah. It's a really cool sounding project though, and it's I hope that it got finished to at least to a point where it was useful and hopefully helped lots of babies with hip dysplasia. Yeah,
I hope so too. We were doing the first part, and so like all the kids that were going to come after us were supposed to like finish it up, and then we had plans to like branch out into other like biomechanical groups, but I don't know. I should follow up on that. I'll follow up on that and get back to you.
We'll put it in the description or something. They did well.
Yeah, my paper is published. If you wanted to look it up, so
that's cool.
That's very.
How do we find it?
That's
What are we? Other titles or something?
I'll send you the link.
Okay, we'll do that. Okay. I'll make a note here.
Now, if you had no limitations at all, money, space, time, a team, if all of these things were no object, what would you do? Like, it sounds like you've done stuff. Obviously, you've done biomedical stuff and you've done aerospace stuff and you've done all sorts of stuff. But like, if there were no limits, what would you do? What would you make?
If I was being selfish, I would print an extra pair of hands.
Oh, that would be rad. Yes.
Like biomechanical hands, like Doc Ock. Like I would just have them like popping out of my shoulders. That could like, so that I could type and then like drink coffee at the same time.
Yes.
But yeah, so I would just have some biomechanical arms.
That is very cool.
Yeah, if I wasn't being selfish, I would print homes. Like I would just level everything and just start printing homes. I worked on a project a couple years back that was about printing on Mars. So they had this idea that we would send the rover to Mars, and then the rover would scoop up the regolith, which is like
the basalty
a fancy
stuff,
way
right?
of saying dirt.
Yeah.
And then it would like dump it into a vat behind it, and it would mix it like cement, and then it would use that as material for extruding and making homes. So they would send that out first, and then they would send the astronauts.
Yeah,
I think it was in America Makes, and then like the astronauts would come after that, and like once the astronauts got there, they'd show up and be like, "Yo, it built our house. Like we don't have to sleep outside."
That's so cool. I didn't know you worked on that. That's awesome. I've like been thinking about that ever since I heard about it. I'm like, that's freaking genius. That's amazing. Yeah, like little robot printers, like little. Mm-hmm. Yeah, so cool. Wow.
But I
didn't know you worked on that.
Right?
Dirt, like
just the coolest
using
human.
Mars dirt is kind of amazing to just like be
They
like,
don't
yep.
have trees.
Huh?
It's like they don't have trees, so you get there. It's like, I guess we're gonna use this dirt.
Make some little mud brick houses.
Use what you got. Use what you got. I still really like the Doc
very
Ock
sustainable.
Arms, so I think I would like some Doc Ock style arms, please. That sounds good.
Mechadendrites.
Yeah, honestly, I could definitely use a couple sets, like one above, one below. Like that would be. It's not selfish. It's big brain.
Yeah.
Galaxy brain.
Oh, this has been so great. Thank you so much for coming on. Like, I have thoroughly, my cheeks hurt from smiling so much. This is wonderful.
My brain is very full. Of new information, but I still think that the coolest thing that I learned today was about Inconel. Like, that's the vibranium. I'm taking that with me.
Yeah. It's pretty awesome. I had to name myself after it, but
I love it.
Just to put it out there in the community, Inconel comes in Inconel 718 and Inconel 625, and those are the two types of Inconel that we generally tend to print with. I mean, there's other numbers, and the numbers represent like something like periodically, like the chemistry of the material. But yeah, so like it's like, do you want Inconel 718 or Inconel 625? And so when I called myself Inconel, people would message me and be like, so is your birthday like 625 or is your birthday 718? And I would just be like, you're cute, but thanks.
That's like a science.
That is kind of cute, though. That would get me. Anytime someone works out what my name means, I'm like, yes, go you.
Like you've done your homework. Your homework.
Well done. That's awesome. Oh, people are great. I love them.
People are something. That's for sure.
Was there anything else you wanted to chat about before? Like, is there anything else you wanted to talk about today? Tonight? The morning?
I feel like I've just done a lot of talking for like the last hour.
That is the point. It is an interview.
Right. I'm sorry. I'm used to being like the silent engineer on the wall. That's kind of in my head. Like, that's never going to print. That's never going to print. Never going to print. Okay, we're going to print it.
Screaming.
Not today. It's above my job description. I just push go.
Today the spotlight's on you.
But yeah, I guess if there's anything that I wanted to chat about or have like put on the interview, it would be that I hope a lot of the makers in your channel that are watching this, like especially the younger ones, because I noticed that you have like a good amount of like younger high school age like makers that follow you. Go into metal printing. Like, it's awesome career. It's fantastic, and we need more people in metal printing to keep it going. And even if you don't like metal printing, like higher level industrial printing is also like really cool too. I mean, I love that the maker community is, they're really obsessed with like the open source thing, but like there's like a little bit of luxury in like the corporate side where you can just like push a button and then Stratasys will ship you the material and then you just kick it in the machine and it just goes. It's a lot easier in certain regards. I love the open sourceness, but I'm also like, come on, try the dark side just a little bit. Taste it.
There are some
try
trickies.
A little bit.
That stuff's not going away. So yeah, it's not going away. So might as well take advantage.
If you work in the industrial sector, I mean, you don't have to pay for it. Like, another company is paying you to print, and it's awesome getting paid to print.
That is cool.
I'm paid to print. I love it. I do it at home whenever I get the chance. I don't have a printer here. Don't judge me. Don't judge me.
Not judging you. You have amazing printers you work with every day. Like, why would you need one at home?
Yeah, I think my wife would kill me if like I had a printer at home because I print all day long, and then to come home and sit there like printing again. Like, do you ever stop?
Did she come first, or did printing come first? Which came first in your life, her or printing? Like, in timeline wise, like, which did you meet first?
You were setting me up.
Okay, we won't answer that question. I'm sorry, SJ's wife.
not get you in trouble.
I feel the same way though. Like I feel like I neglect my poor partner sometimes. Like maybe it would be better if I didn't have my printers hit because he might get more me time. Poor thing.
Exactly.
Poor
So
thing.
I'm just
Yeah.
like trying.
You made the right choice,
Sorry.
to be perfectly honest. Well then, where can people find you if they want to follow you and continue gazing in awe at your amazing works?
Well, you can find me at Inconelle, INCONELLE, on Twitter. And you can also find me on LinkedIn under SJ. I don't know how many SJs there are, but I don't think there's that many. If you want to follow me and see what I'm doing, like, in the corporate world. I'm trying to, like, so, like, there was this first wave of, like, metal 3D printers that were, like, super old, guys. Right. Like, they were really old. And so, like, now I'm in, like, the second wave. And so, like, we're just constantly, people in the second wave are kind of like, can we post that? And the old guys are like, no, you can't. And then we're like, well, how are we going to tell people that we're awesome? And they're like, okay, you can post this one thing. And I'm
very
like,
highly skeptical of the internet. Yeah.
Yeah. And I'm just like, okay, fine. Like, I'll just post the one boring picture of the printer outside, like, in the middle of the parking lot. Like, that's fine. It's gonna get me all the likes.
Yep.
Aw, that's a shame.
But yeah.
I get that.
If you follow me on LinkedIn, there is a video of, like, what I do every day, and I can share it with you.
Yes.
I can also
pop
share it with you in the
links.
comments because it is on LinkedIn.
Yeah. We'll put those in the description. We will do that because that would be awesome.
Okay, perfect.
Yes. Oh, thank you
Thank you so much for getting up early to join us.
Very early. Thank you. Thank you. This was
You're
awesome.
most welcome.
I love every time I get to spend with you and Faye, and this is just
Agreed.
like the best time right here. So thank you.
Yep. Absolutely.
Yes, we should do this more. Well, I will see you on the internet. Thank you once again.
See y'all next time.
Yeah. Bye. I am loving making this series, and if you are too, please support me on Patreon so I can keep making more. Top supporters will appear in this list of legends, and the topmost supporter gets a special shout out, so thank you, Loyal Moses. You are absolutely wonderful. I know you don't only support me, but so many others in the community, and you're awesome for it. Thank you. You can meet another maker here, and here's a video YouTube thinks you'll like. If you want to catch up with any of us, all our socials are in the description below. See you later!